I am Mikel Vildones, and for my fifth laboratory activity in Data Communications and Networking 1, I was tasked to create a Cisco-based web programming system and my own corresponding website and link. So I can determine the function of the server in networks and identify how the server responds at the client's request. So the setup I have over here is derived from the guidelines given in the laboratory manual. So basically, I have three PCs and then three servers and then two switches. These are straight through cables, and this is a crossover cable connecting the switches. And the setup for the first two PCs is that they should have a dynamic server which corresponds to that of the DHCP server. Sorry, a dynamic IP which corresponds to that of the DHCP server. So we will talk about DHCP later, its meaning and its function in how this or function and or purpose in how the network functions or works. So yes, as we can see, the DHCP is enabled and the IP address of our DHCP server is being followed by PC0 and PC1. You can see, hold on, it is lagging. Yeah, yep. So it is following our IP, our respective IP address set from the DHCP server, which I will show right now. And hold on, let me just close one of the PCs. Oops. Wait. Oh my goodness, the lag. Here. Um, so yes, it is following the IP address, the default gateway, in other terms, and our HTTP is off, our DHCP is on, DNS off, email off. Okay, that's good. Now let's move to our DNS server, and uh, it follows the same gateway as the DHCP server, and HTTP still off, DHCP now is off, and our DNS is over here. So these are the links that I was able to set up based on the guidelines given in the laboratory module. So this one, then go on to the web server, our third server here in this networking setup that I have created, and it is named www.amaes.edu since that is what the lab manual said, and we are going to test it now to see if it works on our one of our dynamic PCs. So for this, obviously our HTTP has to be turned on in order for it to work. So we have, yeah, I turned it on, and I think I'm here at the PC right now. We can test to see if our website works. So we're gonna test it to see if amaes.edu works. And to do that, we must go to our PC and access the web browser and type in our link. So let us wait for it to load. And here we go. www. Wait. www.amaes.edu. Let's go. And as you can see, it works right here. AMA Online Education. This is a text that I edited on the web server. Oh, originally, Cisco Packet Tracer gave us a basic format with these links, and this one used the blue text used to be Cisco Packet Tracer, and this line of text here originally said "Welcome to Cisco Packet Tracer so and so." So with that, I was then tasked by the lab module to create my own website based on one of the other links given, on the other web address and link given, which is www.internal.com, and based on how I created amaes.edu, I was also told to configure internal.com to my own specifications. So with that, let us go. But before we go, let's see how let's go back to the AMES DH server. So this is how um, to configure our link. So copyrights, I didn't delete that. It is part of the original file. Then this is the logo of Cisco Packet Tracer. Then hello world. This is where I edited. This is where I edited the text that was originally supposed to show in one of the links that stem from the original web page of amaes.edu, or no, sorry, Cisco Packet Tracer. So a www.amaes.edu. So here we go. And here, this is the one. This is what I'm saying. Hello world. So okay, hello world is done. This is the logo. I believe this one. This is the logo over here. Image of Cisco logo. And in the internal.com website that I am going to show to you, I will show you how I modified or the modifications I did, in this web page in order to fit the specifications or the guideline given by the lab module, which is to create a website based on or that talks about artificial intelligence. All right, so here is my web server that I modeled based on the previous one, only that it now reads www.internal.com. Going to the web server, let us check the components of the web server. So over here, HTTP. Yeah, correct. Um, I simply replaced the hello world, the link leading to the hello world contained hello world, and I simply replaced it with an article on artificial intelligence. And I was able to import my own images, although for previous tries they did not work off camera, and I wonder if they will work right now. Onto our website, and then this is supposed to be an image of our AI article. Okay, let us save this. We can overwrite that, and let us now go to our PC and enter the link. So as you can see, our web page over here has been configured based on um, the modifications that I did to the components of our website. So we can just check the four links over here. So a small page. This is originally the Hello World page, and as you can see, it has been replaced by an article that I um, obtained about AI. Copyright. I deleted it, so it will not reflect over here on our website. The image page, unfortunately, the image won't load, but as you can see, it has been placed right here, and that means that our process is somewhat successful, even if the image did not load, as it has been successfully imported onto the our web page. Anyway, I could deem this as a success, even though it is not a complete success, since I was able to modify the web page as much as I could to talk about artificial intelligence and demonstrate how a web server works. So now let us answer the questions given in the laboratory manual, starting with the meanings or of HTTP, DNS, and DHCP, which are components of our network server or of our network and our servers. So these are three fundamental protocols used in networking. First is HTTP, or Hypertext Transfer Protocol, and that is what we use to get our website working. And it is a protocol used for transmitting data, which is text, images, videos, and etc. over the internet. It is the base of communication between web browsers and web servers, enabling users to access and share information online. So, as I demonstrated, when you enter a URL or click a link, your browser or the browser on the PC sends an HTTP request to the server, which corresponds with the requested sources. Now let's move on to DNS, or domain name system, which acts like a phone directory for the internet. It converts human readable names or domain names into IP addresses that computer uses to communicate. When you enter a URL, Your browser on the computer sends a DNS query to the DNS resolver, which looks up the IP address associated with the domain name, which is basically the purpose of our DNS server. And then next is the dynamic host configuration protocol, which is a protocol that assigns IP addresses and other network settings to devices on a network dynamically. So when you connect to a network, the device sends a DHCP request, and the DHCP server assigns an available IP address, subnet mask gateway, and other settings, allowing your device to communicate with other devices on the network. So basically, how it works is that um, our computer requests for an IP address. So once it does that, the packet it will send a data packet through the switch and then onto our DHCP server. Afterwards, the DHCP server will reply with the data packet, and the data packet contains the IP, the assigned IP for our dynamic computers. And then when we type a link, our computer send the data packet to the DNS server, by which after which the DNS server replies with IP addresses that computers use to communicate. The IP address being the IP address associated with the domain name, or the domain name of the website that we are looking for. So it will send the data packet back to these dynamic computers, and then after that, it will send it to the server, our web server, and then after which our web server will respond with the website itself and the corresponding contents of the website. So that is how it works. And we can now go to question number two, which asks us to differentiate web design using HTML as compared to Cisco Packet Tracer. So first, what is HTML? It stands for Hypertext Markup Language, and it is used for creating web pages. So as it is used for creating web pages, it is standard for web development, and it is used to structure and format content on the web. HTML files are stored on web servers and transmitted to clients or web browsers via HTTP. Now for Cisco Packet Tracer, which is what I'm using to simulate my network. So it is a tool for simulation used for designing, configuring, and testing computer networks. Although primarily it is used only for educational purposes, such as demonstrating networking concepts and protocols in order to simulate network traffic. So the main differences between these two are the following: are the purpose. That's number one. Since HTML is used for the real life applications or the real world applications, while Packet Tracer is merely used for educational simulation. The scope is of HTML is on web content itself, while the Packet Tracer focuses on the infrastructure of the networks, hence why my website a while ago looked a little bit bland or a little bit basic. And then the output of HTML is of course legit web pages, while Packet Tracer generates simulated network environments or just the structures of the web pages that I searched up and opened. So that concludes our laboratory exercise for today. My takeaways from this activity are that I understood the basics of HTTP, DNS, and DHCP, and how they are essential for working with web development and networking. I also was able to differentiate HTML and Cisco Packet Tracer via their purposes and their scopes and their outputs. And then the familiarity with HTML and network simulation tools such as Packet Tracer and the comprehensive understanding I got from them. And also, I also took away basic networking fundamentals and how they are interconnected with web development in enhancing my skills in computer science, IT, and my course, computer engineering. So that wraps it up for this laboratory exercise. Thank you for watching and have a good day.